Hello viewers, in today's class we are going to solve one important problem from definite integrals, right? So here we have an important problem, that is we have to find the value of this integral from -1 to 1, and here we have the integrand, that is e raised to x plus signum of x, right? So here we observe that in the integrand we have the function that is signum function, right? So here in order to evaluate this integral, what we have to do, we have to make use of the definition of signum function, right? So let us start, and let us first call this integral as I, right? So now here, before proceeding further, let us quickly see the definition of signum function, right? So now we know that signum of say y is defined as +1 whenever y is greater than 0, right? And signum of y takes the value 0 whenever y is equal to 0, and signum of y takes the value -1 whenever y is less than 0, right? So this is the definition of signum function which we are going to use while evaluating this integral, right? So now let us first see the limits here. The lower limit is -1 and the upper limit is 1, right? So here we are representing the numbers -1 and 1 on the number line, and we see that between -1 and 1 we have the integer 0, right? And here this integer 0, it plays a significant role because see, when we break this integral as a sum of two integrals, say I1 and I2, right? So we'll split this integral as a sum of two integrals, because here we have the signum function, and the signum function allows us to divide this integral as a sum of two integrals, right? So first we will take -1 to 0, because when x belongs to this interval, that is -1 to 0, then all the values of x which lies in the interval -1 to 0, they are all less than 0, right? So here we'll have this condition for signum function, right? So here y is less than 0, so here we have x less than 0 from -1 to 0. So when x less than 0, then signum of x will take the value -1, right? And in the second integral, when we go from 0 to 1, that is when x belongs to 0 to 1, then all the values of x which lies in the interval 0 and 1, they are all greater than 0, right? So in that case we'll take this definition, right? That is y greater than 0, so signum of y takes the value +1. So when x belongs to 0 to 1, then signum of x must be equal to +1, right? And at x is equal to 0, the signum of x, it takes the value 0, right? Due to this definition, right? So now what we will do, we'll write this integral as a sum of two integrals. So we can now write I is equal to, I1 is from -1 to 0, and we have e raised to x plus, and see here we have signum of x, right? So when we go from -1 to 0, signum of x will take the value -1. So here we'll have -1 and dx, and I2 is from 0 to 1, right? And we have e raised to x plus, here we'll have x plus, signum of x will take the value +1, right? So here we'll have +1. So now we have these two integrals, So now we can rewrite these two integrals as -1 to 0, and here we have e raised to x minus 1 dx, and this is from 0 to 1, and this is x plus 1 and dx, right? Okay, so now here we'll make use of the standard result from indefinite integrals, that is the integral of e raised to y is e raised to y, right? So here the integral of e raised to x minus 1 is e raised to x minus 1, and the limits are from -1 to 0, and here the integral of e raised to x plus 1 is e raised to x plus 1, and the limits of integration are from 0 to 1, right? We can also solve these two integrals by the method of substitution, right? We can take y is equal to x minus 1, and then the usual steps of method of substitution may be employed, right? So now we'll substitute the limits and we'll take the difference. So here we have 0 minus 1, then we can take x is equal to -1. So here we have e raised to -1 minus 1, and then here we have 1, so this is 1 plus 1, and then here we have x is equal to 0, so we have 0 plus 1, right? So now we can simplify it. So this is e raised to -1, this is e to -2, and here we have e square, and here we have e, right? So the value of this integral can be given by this expression, but we can now simplify this expression further by making use of the hyperbolic functions. Now see, this expression can be written as e square minus e raised to -2. If we combine these two terms, then we'll get this expression, and if we combine this e and this e raised to -1, then we can write minus e raised to -1, right? Okay, so now here we'll make use of the hyperbolic functions, and we know that the hyperbolic function of sine is given by e raised to x minus e raised to -x over 2, and hyperbolic function of cosine is cos hx is equal to e raised to x plus e raised to -x over 2, right? Now since these two are very important hyperbolic functions, so here in our problem we'll make use of only this result, right? So see, because here we have e raised to x minus e raised to -x, and both these terms have a negative sign between these two terms, right? So here we'll make use of only this result. So we can now write e raised to x minus e raised to -x is equal to 2 times of hyperbolic of sine function, right? So now if we take here x is equal to 1, and then we'll get the expression e raised to 1 minus e raised to -1 is equal to 2 times the hyperbolic of sine 1, right? And if we take x is equal to 2, then we can write e raised to 2 minus e raised to -2 is equal to 2 times the hyperbolic of sine of 2, right? So now what we will do for this term, we can write this expression, right? And for this term we can write this expression. So now I can be written as see 2 times of sine h2, that is hyperbolic sine of 2, and then here we can write 2 times of sine h1, right? And if we take 2 common, we'll get the sine hyperbolic sine of 2, and here we have sine h1, right? So the value of this integral is equal to this expression, right? And here in this problem we have seen that how this integral involving signum function is related to the hyperbolic function of sine.